This video is on complex fractions, so we are on page 9 of that note packet. So a complex fraction is when you have a fraction within a fraction. So you have fractions either in the numerator of a fraction or a denominator or maybe even both. So our goal is to get rid of those fractions. So you want to multiply the top and bottom of that fraction by the least common denominator of the fractions within the fractions. So I have this example. I'm showing you the same example twice, just showing you different work. So we have 2/3 divided by 4/5. So if I look at my denominators, I have a denominator of 3 and a denominator of 5 for those fractions within the fractions. So my least common denominator between a 3 and a 5 is 15. So I need to multiply that whole fraction, that top part of the big fraction by 15 and the bottom portion of the big fraction by 15. So 2/3 times 15. So remember, when you're multiplying, you multiply straight across. So it's 2 times 15 gives us that 30. That 3 remains unchanged because that's like 15 over 1. And then 4 times 15 gives us 60. And then we have that divided by 5. Well, from here, we do know 30 divided by 3 is 10 and 60 divided by 5 is 12. So we've gotten rid of those fractions within the fractions. And then lastly, you just reduce 10 divided by 12 is 5 over 6. Now that's showing all of the work. I'm not going to show it for every single problem. However, a shorter way of looking at it is, again, you're multiplying by 15, but you look to see what cancels out because there will always be something that cancels for the most part. So here, if I have 2/3 divided by 15, I can just look at it. 15 divided by 3 is 5. And then here, 4/5 times 15, I can look at the 15 divided by 5. That will reduce to 3. And then I can multiply straight across. 2 times 5 is 10, 4 times 3 is 12, and then again reduce that fraction to 5/6. So we're going to take a look at a few examples, starting with example number 1. Looking at example 1, we want to simplify this expression. So what we're doing here, we want to find our least common denominator, just as if we were adding or subtracting our fractions. So here I have a denominator of x, a denominator of x, so our least common denominator is x. We're going to multiply the top and the bottom of this fraction by x. So what we're doing now is distributing this x inside to both of these terms and this x into both of these terms. So I'm going to show you what that looks like. You won't have to show this step every single time. Some of you will be able to see what cancels in your head. So this x has been distributed, so we have 2x over x, and then 4x, and then again 2x over x plus our 3x. So what you're going to see now is that these x's cancel, and then we have in our final answer just the 2 minus 4x and the 2 plus 3x in the denominator. So the way to get around that, think of it as when you're distributing this x in here, it's going to cancel that with that denominator, so you're just left with the 2. But the x still has to go to the -4. Same thing here, the x still has to go to the 3, but when you distribute it, the 2 divided by x, since you're multiplying and dividing by x, they're going to cancel and you're just left with the 2. So now looking at letter B, we want to find, again, that least common denominator. We have an x plus 5, an x minus 3, and an x plus 5. So our least common denominator is going to be that x plus 5 and the x minus 3. So what we're doing, we're going to multiply that entire top fraction by x minus 3 times x plus 5, and then again that whole bottom one by x minus 3 times x plus 5 as well. So what you're going to notice here, again, I'm going to show this side work over here. You do not have to write all of this down unless you wish to. But what we're doing is we're doing 3 times x minus 3 times x plus 5, all of that divided by x plus 5. And then again, we're distributing both of these binomials to both fractions, so you can see how that's rewritten here. And then what happens is you see this x plus 5 and this x plus 5 here, those are going to cancel. Same thing here, you have an x minus 3 over an x minus 3, they will cancel. And then you have an x plus 5 over an x plus 5, so those will cancel as well. So what you are left with is just the 3 times x minus 3, 2 times x plus 5, and then this 1 times x minus 3. And if you don't want to show all of this work, it's still possible because you're doing 3 times all of this divided by that. So you're taking this denominator and canceling it with what you're multiplying by. So you're just left with that 3 over x minus 3. Same thing here, you're taking both of these binomials, multiplying them into each fraction. So the x minus 3 will cancel with this x minus 3 for this fraction, so you just have the 2 times x plus 5, and then when you're multiplying these to this fraction, the x plus 5s will cancel, leaving the 1 times x minus 3. So from here, we can get rid of our parentheses by distributing. So 3 times x is 3x, negative 9, distribute the 2, distribute the 1. And then lastly, we combine our like terms to get 3x minus 9 over 3x plus 7. I'm going to do 2 more examples. So we're going to skip to letter B in that bottom portion here. So we want to simplify the complex fraction, so we're looking at the lower level of letter B. So again, I have this denominator of x, this denominator of 5, so that least common denominator is 5x. So we're multiplying both the top and bottom by 5x. So this 5x times 15, that's going to give us 75x. And then again, 5x times 2 divided by x, the x's are going to end up canceling here. So we're just left with that minus 10. Same thing here, when you distribute the 5x to the x over 5, the 5's will cancel, but x times x gives you this x squared, and then 4 times 5x gives us 20x. And then always look to see if you can simplify some more. I do have a GCF in the numerator of 5. I do have a GCF in the denominator of x. So if you want to take those out, you can, but since these do not simplify in the end, either one of these is good for your final answer. The last one we're going to look at is letter D, still in that lower section here. So this looks like a lot. So we have x minus 2, x squared minus 4, x plus 2, and x minus 2. This denominator of x squared minus 4 is what jumps out at me because I know that's a difference of 2 squares and I can factor it. So we want to factor it to help us determine what our least common denominator is. So you see we have these x minus 2's, so those are part of our least common denominator. And what's left over is also our x plus 2's. So our least common denominator is x minus 2 times x plus 2. So we're going to go ahead and multiply both the top and bottom of this fraction by both x minus 2 and x plus 2. So once I distribute this in here, when we multiply to the first fraction, my x minus 2's will cancel, and I'm just left with my 3 and my x plus 2. With the second fraction, the x minus 2 will cancel and the x plus 2 will cancel, leaving us with just that negative 6. Again, it's a minus because that's the subtraction sign there. For the denominator, we're dividing by x plus 2 here. So when we multiply, the x plus 2's will cancel. So we're just left with 3 times x minus 2. And then the x minus 2's will cancel for our second fraction. So we're left with 1 times x plus 2. We can distribute all of our coefficients to get rid of our parentheses. And then we can combine our like terms. So the 6's are going to cancel out, and we can combine our like terms in the denominator. I do see I have a 4x minus 4, so I can pull out a GCF of 4 here, and I'm left with 4 times the quantity x minus 1. But since this does not simplify, I'm okay with this being your final answer as well. So either one of these works. Now for some extra practice, you should try letters B and C on page 9, as well as complete numbers 1 through 6 on page 10. That's some review on adding, subtracting, as well as one with your complex fractions that we just did.